BMAT205 Lab9. Typical question: two investments given. One gives you interest rate per year, and the other one is compounded annual for the next 5 years. We want to find which investment is better. Let's take a look at example problem 2. We want to find future value, assuming that we invest in $100 with investment 1. In the first year, we're going to have a return of 8%. So $100 times 1 plus 0.08 divided by 12 to the power of 12 because it's compounded monthly. In the second year, that becomes present value at the beginning of the second year with investing for 1 year at 3.75%. In other words, 1 plus 0.0375 divided by 12 compounding periods per year to the power of 12, and then we repeat that process for the next 3 years to calculate future value of $100 invested at the beginning of the first year until the 5th year, and that gives us $118.18. We'll do the same thing with future value of investment 2, and in this case we're investing $100 at 3.32% compounded monthly for 5 years, or 5 times 12. Compounded monthly about 5 years, and that produces $118.03. So 118.18 is slightly larger, and we select option investment 1 as a preferred investment. Question 5, a typical question: a credit card company either wants to add or reduce the effective interest rate they're currently charging. So in the first case, we want to find, in first step, we want to find current effective interest rate, and the current effective interest rate, given that nominal rate is 4.75% compounded quarterly, using the formula we have F current is going to be equal to 1 plus J over M to the power of M, and then minus 1, that's the formula, which is equal to 1 plus, in our case the nominal rate is 0.0475, and compounded quarterly, so divided by 4, and raised to the M equal 4, and then minus 1 times 100% gives us 4.83528%. That's the current effective rate. Now in step 2, we want to find the new effective rate, which we subtract from the current one, 2.7%. Sometimes we subtract, sometimes we add. We have to read the question very carefully. So in this case, we're subtracting 2.7, so the new effective rate is equal to 2.1352. And in step 3, we want to convert the new effective rate to the nominal rate, J nu, and that produces our 2.12%. We do that by using a regular formula, so we're transforming the formula. F nu is equal to 1 plus J nu over M to the power of M minus 1, and we want to solve for J nu. So we're adding 1 to both sides, so we'll have F nu plus 1 is going to be equal to 1 plus J nu over M to the power of M. Now we're exponentiating both sides, exponentiating both sides to the power of 1 over M. So F nu plus 1 to the power of 1 over M is going to be equal to 1 plus J nu over M. And in solving for J nu, we'll get J nu is going to be equal to, using a calculator, we'll have 1 plus 0.01352, which is the current rate. And using the financial calculator, we can find step 1, effective rate equal to 4.75, 4, enter, and then subtract. In this case, subtract 2.7%, that's what they want to reduce. So the new effective rate, that's step 2, is equal to 2.13528, exactly what we had before. Now we want to convert that rate to the nominal, so we go to TDM and look for NOM, which stands for nominal, and we input 2.135, which is second function answer, comma, same number of compounding periods 4, and enter, and we have exactly the same 2.12%. They ask us to find the answer between 2 decimal places, rounded to 2 decimal places. So 2 places after the decimal, that's 2.12% in the new nominal rate. Question 4, in this question we are asked to find the equivalent rate. So given interest rate of 8.75% compounded quarterly, we want to find equivalent rate compounded annually. A formula that we have is I sub 2 is equal to 1 plus j1 over I sub 1 to the power of m1 over m2, substituting values, and then solving for j2, we have j2 is equal to 9.04. So 9.04% compounded annually is equivalent to 8.75% compounded monthly. And we'll see that, and we'll repeat the process for the next 4 problems.